Okay, another factoring shortcut video. This one is pretty slick. There's something called difference of squares and perfect squares. If you can recognize that a problem is difference of squares or perfect squares, you can just write down the answer and you're done. But it's a little more difficult to recognize it. Again, your multiplication tables and your mental math skills need to be pretty on point to recognize these. If you don't recognize it, that's okay. Just use box method or factor by grouping and just figure it out, and you're going to realize eventually, like, oh yeah, okay, I could have done that shortcut. But let's just get into it. Pretty slick shortcut that just, you go straight to the answer. Okay, the word difference in math means subtract. So when I'm doing difference of squares, that means I'm subtracting two things that I can take the square root of. So like if I have x squared minus 9, this is considered difference of squares because I can take the square root of this, because this is x squared, and I can take the square root of this, which is 3 squared, and I'm subtracting it. So difference of two things that are being squared. So the answer for difference of squares, I just go straight to my answer. What you do is you take the square root of both pieces. So I have an x and a 3. I'm going to put those in here. I have x and 3. One of the answers is going to be a plus. One of them is going to be a subtract. And that's it. Pretty slick. Let's try another one, maybe a little more complicated looking. Let's say we have 25x squared minus 81. Okay? I'm looking at this. I'm confused. It's bigger numbers. And then I'm like, wait a second. I'm subtracting two things that I can take the square root of. 25x squared is really, if I were to take the square root of that, I get 5x. Square root of 81 is 9. So I'm like, wait, difference of two things I can take the square root of? Sweet. Go straight to the answer. One of them is going to be a 5x plus 9, and the other one's going to be 5x minus 9. And there are ways to actually work this out. You know, if I want to use the box method or X factor or factor by grouping, any of those work. But again, if you recognize, you go straight to the answer and you're done. There is one way I can try to make this more difficult where it's harder to see, but it's still possible. Like, let's use a smaller number so you can kind of see what I'm doing here. But let's say we have 8x squared minus 18. Okay, well, initially I look at this and I'm like, ooh, it's subtracting. Maybe this is difference of squares. But I can't take the square root of 8. That's an ugly decimal. And I can't take the square root of 18. That's ugly. But what I can do is I can take out a GCF of 2. 2 goes into both of these. So let's say I were to factor out a 2. That would leave me with 4x squared minus 9. And then I look at this again and say, okay, I'm probably done, but just to make sure, is this factorable? Could I do this? Wait a second, yes. Subtracting, I can take the square root of this, and I can take the square root of that. So my answer, this 2 is going to be stuck outside the answer. I take the square root of both of these two pieces in the parentheses. I have 2x and 3. So I've got a 2x and a 3. One of the answers is positive. One of the answers is subtracting. And there we go. There's my answer. Notice that this 2 is stuck on the outside. Magic. Let's do another one of those. I can see some of us are a little confused, so let's just try. And I'm going to tell you what's going on in my head. I'm going to use two things that I can take the square root of, like 16 and 49. But I don't want to put a 16 and a 49. I want to multiply it by a 3. So 16 times 3 is 48. So let's have 48x squared minus 49 times 3 would be 147. Now there's no way that can be factored, right? Well, what if I were to divide both of these by a 3? So if I divide this by 3, so I'm going to take a GCF of 3 out, that ends up being a 16. And then this divided by 3, 14 divided by 3, 4 goes in with 2 left over, 27, 3 goes into 27 9 times. So then what about this? Can I factor that? Yes, I can. I can take the square root of those. So I have a 3 on the outside. Square root of that is 4x. Square root of this is 7. So that means I have a 4x and a 7. One of the answers is positive. One of the answers is a subtraction. And there we go. Pretty slick shortcut. Doesn't really take much work, especially when you're in higher math. You want to save as much time as you can. If you recognize these things, it can make it really quick. So that's difference of squares. Let's go over perfect squares really quick. Perfect squares is when both parentheses end up being the exact same thing. So difference of squares, one was positive, one was negative. But when it's perfect squares, both parentheses end up being the same thing. And so the shortcut for this one, what you have to try and recognize when you're looking at the problem, is you should be able to take the square root of the beginning, and you should be able to take the square root of the end. Now the middle part though, so when you're checking this, the middle part should always be the square root of the beginning times the square root of the end. So in this case, I've got 2x and 3. So if I were to multiply those together, I get 6x. And if you double it, that should be what the middle part is. So this would need to be a 12x. Okay, so if you recognize that, if you see it, here's the answer. We go straight to square root of this is 2x. Square root of that is 3, and then both parentheses are going to be whatever that sign is, both of them. Now recognize both of these are the same, so they can collapse down into one parenthesis. I've got 2x plus 3 squared, and that's perfect squares. Let me show you another one. You can kind of see how my brain was trying to figure out what that middle part needs to be. Now I'm looking at this like, okay, it sort of looks like it might be perfect squares because I can take the square root of the beginning and I can take the square root of the end. I'm not sure if it is. Can I go straight to this answer? The way to know is if I were to take the square root of the beginning, square root of the end, 3x times 4 is 12, and then double it, it gives me the middle. So I'm like, oh, sweet. So this answer is just going to be one parenthesis squared, because it's collapsed into one, 3x, 4, and the sign is a positive. So there we go. There is my perfect squares. Really slick, really fast. Let's do one with the subtraction sign just so you see that. All right, so here's another perfect squares. I can take the square root of the beginning, gives me a 1x. The square root of the end is an 8. If I were to multiply those together, I get an 8. And then if you double that, I get a 16, which is what I have in the middle. So my answer, both parentheses end up collapsing down into 1, so I put a squared, and I have square root of that is x, square root of this is 8, and then the sign needs to be whatever's in the middle, so it's x minus 8 squared. Really slick, really fast. The difficult part is when I give you a whole assignment full of stuff, to be able to pick these out when you're looking at the problems. The more you do it, the more you just recognize like, ooh, that one might be perfect squares. Well, how do I check? Take the square root of the beginning, square root of the end, multiply them together, double it, and it has to equal the middle. Same thing with difference squares. You're always looking for that subtraction sign, and then can I take the square roots of the ends? If there's addition signs, there is kind of a sum of squares shortcut, but it involves imaginary numbers, so I'm not going to go over that right now. When I do another video with imaginary numbers, I'll throw that in there. So be looking for that. Hopefully that helps. Quick little shortcut. Let me know if there's anything I can do to help, and we will see you soon.